Hello everyone, in this video let's discuss about the uniform cost search algorithm that can also be called as UCS. If you are new to our channel, please subscribe for more engineering related topics. So if we see the features of the uniform cost search algorithm, it is used to reach the goal node with the least cost, that is with the minimum number of cost we must be reaching the goal node. And backtracking is allowed in the uniform cost search. If you look at the A node, from A we can go to B and we can go to C. If we go from A to C, it is costing me 3. From A to B, it is costing me 2. If I go from A to C, then I will be realized that it is more cost. So I can backtrack to A, and from A I can go to B again. So it is called as backtracking, and it uses the priority queue. So it will be using the priority queue. Who will be getting the more priority? More priority for least cost. More priority for least cost. Who will be having the least cost path? They will be getting the more priority. Node expansion based on the path cost. As I told, who will be having the least cost? They will be explored first. Advantages is gives the optimal solution, that is the least cost method. Disadvantage is can stuck into the infinite loop. So let's discuss when it can stuck into the infinite loop in the later part of this problem. We are taking 3 problem. This is the beginner problem and these are the intermediate problems. Let's discuss them. If we start for the first question, if we start from A I can go to B or I can go to C. So which is of the least cost? From A to C it is 3 and from A to B it is 2. So the least cost is 2. So I will be moving from A to B with the cost 2. Now from B you can go to A and you can also go to D. But you can't go back to A because from A you are coming. Because you can't go to the source. So from B to D it is costing me 1. So 2 plus 1. It will be 3. So the least cost to traverse from A to the goal node D is 3. Now let's go for the second question. From A I must go to the goal node G. So from A I can go to C or I can go to B. From A to B it is 7. From A to C it is 3. So I will select 3 because of the least cost. From A to C I will be moving. From C I can't go back to A. I can go to D, I can go to B. So from C to B it is 2, from C to D it is 9. So I will be coming with the least cost, that is C to B with cost 2. Next, C is over. From B I can't go back to C and I can't go back to A because A and C are all done. Now I can go from B to E. Only one possible path is there. From B to E it costs me 6. Next, from E, I can go to D, I can go to F, I can go to G. But I must go to the goal node G. So what I will be doing? From E, I will be going to goal node G with cost 1. So my total cost is 3 plus 2 is 5, 5 plus 1 is 6, 6 plus 6 is 12. So my least cost to go from A node to my goal node G is 12. Now let's see for the third question. So if we start from A, I must go to my goal node H. From A, which is the shortest path, from A to C or A to B? A to B it is 7, A to C it is 3. So from A to C it is 3. So now from C to B I can go, from C I can go to B or I can go to D. So the least cost is from C to B, that is 2. C to B. Now from B I can go to E directly. So from B to E cost is 6. Now from E I can go to F, I can go to G, I can go to D. So I need to go for my goal state H. So to go to goal state H I must go from E to D only. So E to D my cost will be 3. So same diagram, I forgot to write 3 here. So 3 plus from D I must go to H. So only one possible path is there, D to H. So it will be 13. So if you add them, 13 plus 3 is 16, 16 plus 6 is 22, 22 plus 2 is 24, 24 plus 3 is 27. So the least cost is 20. This is of the possible shortest path. I said backtracking. So if we do the backtracking, that will be the perfect answer. So let's do using the backtracking. So if we want to do backtracking, from A to B, C it will be same. From C to B also same. From B to E also it will be same. Now if we consider from E, I wanted to go to H, so I choose a D. But if you see the least cost, that is the least cost, from E to G it is there. So I will be moving from E to G with the cost 1. But it is not my goal state. I can't reach to the goal state from G also. So what I will do? I will backtrack to E. Now I will be backtracking to E. What is my cost? Again plus 1. So from A to C it was 3, plus C to B it was 2, plus B to E it was 6, plus E to G it was 1. Again I am coming back using backtracking, so G to E is 1. Now among these two, D and F, which is the least cost? F. So from E I will be moving to F. My cost is E to F is 2, but F is not my goal state and I can't reach the goal state using the F also. So what I will be doing? I will be backtracking to E itself. Again it's cost me 2. Now from E I can go to D. Only possible path is left. So its cost is 3. From D I can go to H. So its cost is 13. So if you add all of them, 3 plus 2 is 6. 3 plus 2 is 5. 5 plus 6 is 11. 11 plus 1 is 12. 12 plus 1 is 13. 15. 17. 20. 20 plus 13 is 33. So this is the shortest path using the backtracking method. You must not go with this. You must be going with the backtracking method, because uniform cost search will use the backtracking. So what I showed is, if you move according to the goal, you will be getting the least cost. If you move according to the least cost, you must backtrack it. So hope you understood the concept of the uniform cost search algorithm. If you have any doubt, please comment below. And if you liked the video, please subscribe for more engineering related topics. Thank you.